So today we are treating integrated rate law for zero order reaction. And if you remember very well, we say that rates of reaction is directly proportional to concentration. Let's say the concentration here is A. And that when R, we introduce proportionality constant, this becomes K. So, but in this case where the order is zero order, it simply means when this is raised to power 0. So I know anything raised to power 0 is the same thing as 1, so K times 1. So R is simply equals to K. So we say that for zero order reaction, you know that these concentrations can vary depending on things happening on it, like things like temperature, light, catalyst, and even pressure, name it. So a lot of factors, nature, surface area, can affect it. So in this case, we say that concentration is not dependent, rate is not dependent on concentration. So if we want to integrate this now, we need to remember that rate of reaction is also given by the disappearance or the change in concentration. Here, we are using A here. The disappearance of concentration A over time with time is equals to K. So if I know this, trying to make this order of the formula, you see that this can be the same thing as saying let the negative sign move to the other side, so it becomes minus K. So if I know this now, I simply need to notice that I can also move this. That is I'm trying to make a subject of the formula. I can move this. So cross multiply. So this can be the same thing as saying change in concentration A is equals to minus K change in T. Anytime we are trying to derive this, there is a principle you need to have in mind. You need to make it in such a way that you are trying to get the concentration one side, every other thing to the other side. So at this point, I can now integrate. So I can say integral of change in concentration is equals to integral. I always bring out my constants. I'm allowed to do that in integration. Then integral of theta t. So notice that over here we have 1. Over here we have 1. Anytime you are integrating something, this D, anytime you are integrating something, change becomes with respect to. So assuming I have 2 here, if I integrate, it will be 2 with respect to A, which will be 2A. But in this case is 1. 1 times A is A. So 1 with respect to A, the integral will give me A. But remember that the integral we are talking about here is simply from the initial point it started to the time, to a given time. From the initial to a given time. So it is not an indefinite integral, it's a definite integral. So that means that A, 1 with respect to concentration A will simply be A. So remember that it has a boundary which is T and 0 equals to, this will simply be, I have minus K here. So integral of 1 with respect to T is T. So T times minus K. So with respect to T and 0. So if I know this now becomes, when I have concentration A, upper boundary T, minus concentration of A, lower boundary 0, that is initial concentration, is equals to minus K and T. And notice that this T is when I have upper boundary T, a given time, minus T at 0. And you know that T at 0, time at 0, it's simply 0. That is when you start something, the time there is 0. So it's not like maybe concentration of something can be, let's say, 20 gram or 20 something when you started it. But that of time at the beginning is always 0. So I simply have minus KT is equals to AT minus A0. So I can make this in such a way that concentration of AT at time is the subject formula. So this becomes minus KT plus A, initial concentration of A. So I push it this way so that you can see that this is line straight line graph. This is equation of a line. I have y, this is x, and what is beside x? M, which is the slope. And what is here? C, which is the intercept. So you see it. So which means that if I choose to graph this thing now, which means that if I graph a zero order reaction, it will be such that I will have concentration of A this side, then T on the y, on the x-axis, this on the y-axis. So you can see that the intercept, I will have a graph that runs such that at so points here, I should be having the initial concentration. Then at a point, I should be having my M. So you need to know that. I believe with as we progress, we'll see questions on graphing this. So there you have it. Remember to like, share, and subscribe.